So yesterday we have started heating curve, right? This is the heating curve. On the y-axis you have temperature, and on the x-axis you have time. You have time. Here we have solid. You can say that you have ice. When you increase temperature, at a certain point, solid start to liquefy. This temperature is called melting point. And above melting point, we have liquid. But at a certain time, this liquid convert into gas. This temperature is called boiling point. And above this temperature, we have only gases. Are you getting my point?
Yes, sir.
Yes, sir.
So in the graph, in the heating curve, heating graph, horizontal part, this is horizontal part. Where solid change to liquid. Where liquid change to gas. The point where solid and liquid exist is called melting point. You can see that here we do not have any temperature change. So the energy, still you have provided the energy. So can you tell me where this energy gone? Guess. Saad, listen my question again. Saad,
Yes,
are
sir.
you listening my voice?
Yes, sir, I'm listening.
Saad, listen. Here we have ice, right? Here we have ice. But at a certain time, you can see that this duration, you can see this duration. In this duration, time increases, but temperature remain constant.
Sir,
You
sir, this
provide,
is
you still providing energy. Can you tell me where this energy gone?
sir, this the energy is gone to like break the bonds. It is used for internal energy, like and it is like used like to break the bonds between the particle.
And then, yes, you are right.
And
It increases the internal energy. Then what happened?
then bonds break and
Okay.
move away from each other, and then that's how like um a substance changes into from solid to liquid and liquid to gas.
Exactly. This energy is utilized to change the state. Now listen, here we have solid. This in this duration, temperature remain constant. Temperature remain constant. But you still provide energy. So my question is that where this energy, is utilized? So this energy is utilized to convert the solid into liquid. Now, right? This is called first horizontal part. First horizontal part. This is first horizontal part. So first horizontal part, of the graph is where solid is changing to changing to liquid. Solid is changing to liquid. This temperature is called, yes, this temperature is called
Melting point.
melting point. Very good. This temperature is called melting point. This is the temperature where solid start to change into liquid. Now next part. No temperature change. During melting. Now you can see that no temperature change. Temperature is same. Here we have temperature. Okay. Yes, we are on this point. Now supplied energy is absorbed. Now supplied energy is absorbed and utilized to convert the state from solid to liquid. Solid to liquid. Saad, can you explain it again?
Sir, and like during this horizontal part, what happens?
Hmm. Yes.
So like basically it's where the solid changes to liquid. It's because and like temperature like it's used for internal energy. The bonds break,
Hmm.
like the supplied energy, yeah, it's used to change the state from solid to liquid.
Hmm. Now, Saad, bond is not broken, right? Attraction is broken. Bond is not broken. Intermolecular force is broken. Are you getting
Okay.
my point?
Okay, sir.
Intermolecular force of attraction is overcome. Saad, are you
Sir,
getting
what
my
is
point?
Yes, sir.
uh, sir?
Yes, Sanam.
What is intermolecule force?
Now listen here. Let's suppose here we have water. This is water, right? Sanam, what is the molecular formula of water?
Of water, it is H2O.
H2O. Now this H2O attract another H2O. This line indicates attraction. This attraction is called intermolecular force of attraction. Intermolecular force of attraction. Now, Saad, listen. When you heat, this bond is broken. This intermolecular force is overcome, and now water boil. Bonding is not broken. This bonding is not broken. Bonding remains same. H2O remains same. But intermolecular force is overcome. This force is overcome. When this force of attraction is overcome, water boil, evaporate. Oh, bhai, are you getting my point or not?
Yes, sir.
Now, second horizontal line. Now, second horizontal line. Now, second horizontal line. You can see that here we still have same constant temperature. Again, this temperature is utilized to convert the liquid into gas. So second, now second horizontal part of the graph is where liquid is changing to gas. This temperature is called, yes, Saad, this temperature is called
Sir, boiling point.
boiling point. No temperature change during boiling. Now supplied energy is absorbed and utilized to convert the state from liquid to gas. Liquid to gas. Any question regarding heating cuff? Yes. Any question regarding heating cuff?
No, sir.
Yes, Ami, do you have any question?
No, sir.
Aiza? Beta, do you have any question?
No, sir.
Okay. Now we are moving to another curve. This curve is called cooling curve. Now, cooling curve. Cooling curve. Now, cooling curve. Cooling curve is the same as heating curve. Same graph, same axis. Same graph with few changes. Now look at. I will draw it again. On the y-axis, we have temperature. On the x-axis, we have time. In heating curve start from solid. But in cooling curve, graph start from gas. So in cooling curve, we decrease the temperature. Then we have constant temperature. Then again decrease the temperature. Then we have again constant line. Then again decreases. Then decreases. Starting we have gas. Then we have liquid. Then we have solid. Here temperature decreases. Cooling means temperature decreases. Decreases. On this side we have liquid plus gas. Here we have solid plus liquid. Yes, anyone can tell me this name of this temperature? Yes.
Boiling point.
Sorry?
Sir, boiling point.
When gas convert into liquid, is it called boiling or condensation?
Sorry, condensing.
This is called condensation point. Condensation point. Condensation means gas, when gas convert into liquid, this is called condensation.
Sir,
Yes.
so wait, but sir, couldn't we also say boiling point, like, because it's the same temperature, yeah? Like, for example, we say melting and freezing point of a substance.
Yes, you are right. But here, look at here. Here we convert gas into liquid, right? Not liquid into gas. Basically, we condense gas into liquid. So obviously, this temperature is called condensation temperature or condensation point. Okay. When you convert liquid into gas, it is called boiling. When you convert gas into liquid, it is called condensation, and the temperature is called condensation point. So you look at here. This is called condensation. This is condensation. This is called condensation. This process is called freezing. Yes. Can anyone tell me the name of this process or this point?
Freezing point.
Freezing point. Very good. This is called freezing point. Freezing point. This is called freezing point. So why gas convert into liquid? When you decrease the temperature, you all know that gas particles are very, very energetic. Gas particles are very, very energetic. When you decrease the temperature, they lose their energy. They lose their energy. Particles come closer. Closer means they change into liquid. When you still decrease the temperature, liquid particles release their energy and come closer and become solid. Are you getting my point or not?
Yes, sir.
So now, right? gas particles, gas particles lose their energy and come closer and come closer and change to liquid and change to liquid. This temperature is called, yes, this temperature is called beta
Condensation point.
Condensation point.
condensation point. Very good. Condensation point. Same for the liquid particle. Same for the liquid. Same for liquid. The liquid particle lose energy and come closer and change to solid. This temperature is called,
Freezing
yes,
point.
this temperature is called
Freezing point.
freezing point. Any question regarding heating curve and cooling curve? Any question?
No, sir.
Any question regarding heating and cooling curve? Yes. Beta, do you have any question?
No, sir.
Okay. Now, after the completion of the chapter, I will share the PDF of these notes, right? After the completion of the chapter. Next is effect of pressure and temperature. Effect of pressure and temperature on a gas. Effect of pressure and temperature on a gas. Now, look at the container. Look at this container. Now, here we have gas particles. These are gas particles. These are gas particles. Here you insert a thermometer. This is thermometer. This is thermometer. Temperature is, let's suppose, 30 degrees centigrade. This is before heating. Now heat. Now particles move rapidly. Now these particles move rapidly. Now temperature is increased. Now temperature is 80 degrees centigrade. This is after heating. Now can you tell me what you observe during the heating? Yes. Can you interpret what happened when you heat the gas?
The particles of the gas started moving faster because they gain more energy due to heating.
First effect is they move faster. Why they move faster?
Because they gain more energy.
And convert into kinetic energy. This energy is called kinetic energy. Then move faster. They collide with each other. They exert pressure on the wall of the container. Are you getting my point?
Yes, sir.
So when heat the gas, particles absorb energy. Particles absorb energy. This energy is called, yes, this energy is called
Kinetic energy.
kinetic energy. Kinetic means moving. So whenever object move, energy is called kinetic energy. So when heat the gas particle, particle absorb energy. This energy is called kinetic energy. First point. Second point. Particles move faster. Particles collide with each other rapidly. Particles collide with the wall of the container and exert pressure. Particles collide with the wall of the container. Wall of the container. And exert pressure. And exert pressure. So can you tell me pressure increase or decrease?
Sir,
Increases.
Pressure of the gas increases, decreases.
It increases.
It increases. So it means when you increase the temperature, pressure of the gas increases. So both are directly proportional. Whenever you increase the pressure, whenever you increase the temperature, pressure of the gas increases. Are you getting my point or not?
yes, sir.
Now next is effect of pressure. This is effect of temperature. This is temperature. Now pressure. Next heading is pressure. Yes, what is pressure? Yes, what is the effect of pressure? Now look at the example. Let's suppose we have a gas range. This is a container, right? This is the piston. This is piston. And here we have gas particles. These are gas particles. This is before low pressure. Low pressure. Now this is after. Now you compress this gas. Now you compress this gas. So this is called high pressure. You create pressure. So the particles come closer. The particles come closer. The particles come closer. All particles come closer. Why closer? Because we exert pressure. This indicates high pressure. This is high pressure. Yes. Are you getting my point or not?
Yes, sir.
Now, when you exert pressure, particle come closer. When you compress any gas, particles come closer. They collide with each other. They collide with the wall of the container. Are you getting my point?
Yeah.
So as pressure increases, collision of the particle increases. Let's start to write. Gas particles normally collide with each other. Collide with each other. Collide with each other. And exert pressure on the wall. On the wall of the container. On the wall of the container. So as pressure increases, as pressure increases, collision of particle increases. Collision of particle increases. Any question regarding effect of pressure? Yes, any question regarding pressure?
No, sir.
No, sir.
Okay. Now, next topic is diffusion. Diffusion. This is our first chapter, atomic states of matter. Diffusion. Yes, can you tell me what is diffusion?
Diffusion
Diffusion is a
is the movement of particles from a region of high concentration to a region of low concentration.
Very good, very good, very good. This is called concentration gradient. This is called concentration gradient. Now look at the example. Let's suppose we have gas cylinder. Let's suppose we have gas cylinder, right? This is gas cylinder. This is gas cylinder. We invert this gas cylinder. This is another gas cylinder. Here we have in the lower one, we have bromine gas. Bromine gas. Here we have bromine gas. This is before. But after few seconds, now this is spread. Now this color is spread. This is called diffusion. Are you getting my point or not?
Yes, sir.
Let's suppose this is bromine gas. So Br2 diffuse. You can see that here we have high concentration. High concentration. Here we have zero concentration, very low concentration. So gas particles move. Gas particles move from the region of high concentration to low concentration. This process is called diffusion. Sath, are you getting this point or not?
Yes, sir.
Can you repeat and explain this whole process?
Sir, so basically, like it means like gas, the Br2, yeah, bromine, like it travels like because on one area there was higher concentration. Now, so now after that, the higher concentration, then it like the gas particles travel like to the
Yes.
area of low concentration.
From higher region to lower region. Right?
Yes, sir.
So, so the answer is, what is diffusion? Movement of particles. Movement of particles from the region of high concentration to the region of low concentration. Movement of particles from the region of high concentration to the region of low concentration is called diffusion. Is called diffusion. So basically diffusion is movement of these gas particles from the region of high concentration to the region of low concentration. And diffusion is stopped when equilibrium is developed, when they become uniform. Are you getting my point or not?
Yes, sir.
So next point, diffusion occur in solid, liquid, or in gas?
Gases.
In
Gases
and the liquid.
and
Option liquids and gases.
liquid and gases. Very good. There is no diffusion in solid. Because particles are free to move. So next point, diffusion occurs in liquid and gases. Why? Because particles are free to move. Particles are free to move. Now, can you tell me diffusion in gases is fast or diffusion in liquid is fast?
Diffusion in gases.
Why?
Sir, because gas particles are lighter.
Because gas particles move fastly.
Yes.
Because gases have less intermolecular space. They are far away from each other. So next point is diffusion in gases is very fast because particles move rapidly. Can you tell me why diffusion is not occur in solid? Yes,
Because
Particles
solids
do not
don't,
move.
yeah, they don't move,
particles do
they only
not move.
vibrate
Very good
and
answer.
rotate.
Yes, very good answer. Very good answer. Because particles are not free to move. Diffusion is in solid. Does not occur because particles are not free to move. Now, speed of the diffusion. Speed of the diffusion. Now, speed of the diffusion. Now, I'm trying to find the experiment, right? Diffusion experiment of ammonium chloride. Yes. This is original diagram. We are trying diffusion experiment. Oh, look at the experiment. Let's suppose here we have, this is the cotton wood. This is pure cotton soaked in ammonia. Here we have cotton wool soaked in HCl. So we need ruler, right? Now after some time, now can anyone tell me the MR of NH3? Yes, MR of NH3.
So I think it's 17.
17. And MR of HCl.
36.5.
So which one is lighter? Ammonia or
NH3.
HCl? NH3. So white fumes appear here. Now HCl ammonia react and form ammonium chloride. This is called ammonium chloride. Why this is ammonium chloride? Because ammonia react with HCl and form ammonium chloride. Let's suppose this is the distance covered by ammonia. And this one is distance covered by HCl. So ammonia is lighter. Ammonia is lighter than HCl. So it covers distance quickly. Ammonia is lighter than HCl, so it covers distance quickly. This is A, this is B. A is the distance. A is the distance covered by NH3, while B is the distance covered by HCl. So A is greater than B because of lower mass of NH3. Any question?
No, sir.
Ammonia diffuses more. So ammonia diffuses faster than HCl.
Sir,
Yes.
why is it diffusing near HCl?
Now listen. Ammonia is a gas. HCl is a gas, right? So here particles move. Here HCl particles move. Here ammonia particles move. So because of the lower mass, ammonia covers more distance. Now here HCl react with ammonia and form ammonium chloride. When you heat, now if you heat it again, then it moves to left hand side and right hand side. Are you getting my point or not? When you heat the ammonium chloride, it's sublime and direct convert into ammonia and HCl. So this white mark disappear. This white mark disappear when you heat ammonium chloride. So next point is ammonium chloride is formed near HCl. Ammonium chloride is formed near HCl. Observation. White solid deposit. White solid deposit near HCl. Next point. When you heat it again, it's sublime and white solid disappear. Yes, any question regarding diffusion?
No, sir.
Okay. Beta, anything?
No, sir.
Any question?
No, sir.
Yes, states of matter. Now I am showing you the syllabus of this chapter. Now look at the syllabus. Sad, are you listening my voice?
Yes, sir.
Can you review the whole the syllabus of states of matter? And tell me which topics are left. We have completed this one. Yes,
Yes, sir. You've done all.
we have done this one. Describe the
Yes.
structure of solid, liquid, and gases in terms of particle separation. We have already done this one. Third is
Yes, sir.
describe
We have
and
done.
explain. ये भी हुआ हुआ है. Interpret and explain heating and cooling curve. Describe and explain in terms of quantum molecule theory effect of temperature and pressure of the volume of the gas. Then we have described and explained the diffusion in terms of quantum molecule theory. Describe the effect of relative molecular mass on the diffusion. So we have completed first chapter, right?
Yes, sir.
सनम, आपको मेरी आवाज आ रही है?
Yes, sir.
सनम, ये पूरे नोट्स मैंने बना दिए और इसमें लास्ट में सिलेबस भी लगा दिए है.
Okay.
ये आ जाएगा सिलेबस. Now be ready for the test of this chapter. Whenever I take your class, I will take the test of this chapter. This is the syllabus of the states of matter. बेटे, any question?
No, sir.
सनम, दूसरा चैप्टर क्या होना चाहिए?
Sir, दूसरा chapter atoms, elements, and compounds.
Atom structure and the periodic table, right?
Yes.
Atomic structure and the periodic table. Okay. Yes. Now you can see that we already done this chapter, right? Sanam, you can see that.
Yes.
कि हम कर चुके हैं. हम मैं आपको इसकी भी पीडीएफ भेज दूंगा, ठीक है?
Okay.
We will do it again.
Okay.
In
Thank
the
you.
next class, we will do it again. Beta, any question? Amit, do you have any
No.
question?
No, sir.
Okay. Aiza Suleiman.
No, sir.
Okay. Saad Sanam Umar.
Yes, sir. No question.
No question, sir.
Alhamdulillah. Alhamdulillah.
Yes.
Alhamdulillah. Okay, beta, take care. Allah Hafiz. Be ready for the test of states of matter. Anytime I can take your surprise test. In any class, states of matter, right?
Okay, sir.
I am sending assignment of this chapter, right? Okay,
Okay,
take
sir.
care. Allah Hafiz.
Thanks, sir.
Allah
Allah Hafiz.
Allah Hafiz.